is 11.34. So based on their composition and structure, list these three molecules right here in order of increasing ion forces, increasing viscosity, and increasing surface tension. So the first thing you want to do is you want to sketch the Lewis dot structure. And here's the sketched one. Here's the sketched one for the second species, and here's the third one right here. And then identify the types of intermolecular forces that are inside of each one. Obviously, they all have London dispersion forces. London dispersion forces, remember, are just dependent on the number of electrons in the atom. And it looks like this guy's going to maybe have the most electrons because we've got chlorine in there. Chlorine's got 17 electrons in it. This has got an extra carbon, so it's going to be close. But the second type of force we're going to have is we'll have a dipole-dipole force on this one because we're going to be a little bit polar. You'll see that there'll be a little bit of an attraction for electrons this way. So we'll have a little bit of a negative area and a little bit of a positive area. This guy, none of those, perfectly symmetrical. This guy right here, we got an H connected to an FO or N, so we not only have a dipole-dipole, but a special case called hydrogen bonds that are going to happen between these molecules. So right away we can say that this guy is going to have the strongest intermolecular forces. It'll have the highest viscosity, and it'll have the highest surface tension because it's got these hydrogen bonds right here. It might not have quite as much London dispersion forces as something like this, but that doesn't matter because hydrogen bonds are so much more powerful, especially in molecules that are a little bit smaller like this. I think this would be second because we have a few more electrons in this. Maybe it's equal, but we have a polar molecule. We have a dipole-dipole force right here, which is a little bit stronger than something that has only London dispersion forces. And so this would be third. This would be our weakest intermolecular forces, our least viscous, and our least surface tension-y type liquid here in the propane molecule. That's 34.